I want to share with you today a new topic, aldehydes. Myself, Dr. Digna Varghese. Aldehydes. Aldehydes, an important class of organic compound that contain a carbonyl group or an oxo group, that is CO group. The carbonyl group is bonded to a carbon atom and a hydrogen atom in an aldehyde. Here you can see its general formula RCHO, where R is an alkyl or aryl group. So, in an aldehyde, the oxo group or carbonyl group is attached to a carbon atom or and a hydrogen atom. Some of the most important and familiar aldehydes represented here, you can see here the R group is benzene ring or phenyl group. So it is known as benzaldehyde. Here you can see the benzaldehyde. The aldehyde group is attached to the ortho position to the hydroxyl group. So it is a orthohydroxy benzaldehyde. Okay, it is otherwise known as salicyl aldehyde. Here you can see an unsaturated aldehyde, that is cinnamaldehyde. CHO group is attached to the unsaturated alkene group containing benzene. So it is known as cinnamaldehyde. So these are aryl groups attached to the aldehyde functional group CHO. Here you can see formaldehyde. Its IUPAC name is methanol because it contains only one carbon atom, methanol. Here you can see ethanol. It contains two carbon atoms, 1 and 2. Next, higher homologue is propanol. It contains three carbon atoms, 1, 2, 3. Here you can see the 4 carbon containing aldehyde, that is butanol, 1, 2, 3, 4. So it is butanol. Another aldehyde you can see here, it contains a halogen atom in the carbon chain. We can number it in this way: 1, 2, 3, and 4. So the main chain is butanol, but in the third position there is a halogen atom. Here bromo group is attached to butanol. So it is 3 bromo butanol. 3 bromo butanol. Okay. Preparation of aldehydes. The first method for preparing aldehyde is the oxidation of primary alcohols. Here you can see a primary alcohol undergo oxidation reaction and forming aldehyde and water. We can use the oxidizing agents as KMnO4 in acid medium, or we can say acidified KMnO4, acidified potassium dichromate, or we can use chromium trioxide in an anhydrous medium. So these reagents, one of these reagents can be used for this oxidation process. Oxidation of primary alcohol gives aldehyde. Usually the alcohol undergo oxidation reaction. It will first turns to aldehyde and finally it will oxidize to carboxylic acid. So in order to prevent further oxidation of the aldehyde formed here, the reaction is carried out at a temperature slightly above the boiling point of the aldehyde so that it distills out and we can separate the aldehyde before carboxylic acid is formed. So, in this oxidation reaction, we can use the reagents acidified potassium permanganate, acidified potassium dichromate, or chromium trioxide in an anhydrous medium. Here you can see ethanol undergo oxidation reaction and form acetaldehyde or ethanol and water. The same reagents, any of these reagents can be used for this oxidation process. So primary alcohols undergo oxidation reactions with these any of these reagents, it will the alcohol converted into aldehyde. Another preparation method for the aldehyde, here you can see the same method, that is the primary alcohol oxidized to aldehyde, but the reagent used here is different. Here you can see butanol undergo oxidation reaction and form butanol. Okay, but here using the reagent is PCC. What is PCC? That is pyridinium chlorochromate. PCC is pyridinium chlorochromate. It is a complex of chromium trioxide with pyridine. Okay, and HCl in a solvent like dichloromethane. So here the reaction is oxidation reaction, but we are using the reagent PCC, that is pyridinium chlorochromate. Pyridinium chlorochromate is a complex of chromium trioxide with pyridine in HCl. So here the reagent is PCC in dichloromethane or chloroform, that is solvent. Okay. So here the primary alcohol is that alcohol which the hydroxyl group attached to the carbon. Hydroxyl group attached to the carbon which is attached to the one carbon atom. Okay. So this is the primary alcohol which undergo oxidation reaction in the presence of a reagent like PCC in dichloromethane or PCC in chloroform. It will converted into aldehyde. One special advantage of PCC is that it leaves any carbon-carbon multiple bond in the substrate, that is uncleaved and unoxidized. But in the case of potassium permanganate, it will decompose the carbon-carbon double bond. If this compound is an unsaturated alcohol, by using PCC, it will not cleave the double bond in the parent alcohol. Next method for the preparation of aldehyde is the dehydrogenation of primary alcohols. That is also an oxidation process. Here you can see the primary alcohol are passed over heated copper or silver at 573 Kelvin. Heated copper or heated silver at high temperature, that is 573 Kelvin. The dehydrogenation, that means removal of hydrogen and forming aldehyde. Here you can see ethanol passed over heated copper or silver. It will converted to acetaldehyde by the removal of hydrogen. So this is one preparation method for the formation of aldehyde, that is dehydrogenation of primary alcohols. Here you can see hydrogen is removed from the alcohol by passing the alcohol over heated copper or silver. So the alcohol converted into aldehyde. This method is suitable for the dehydrogenation of volatile alcohols and is of industrial application. Thank you for your attention.